Let's discuss about bond order. Okay, so bond order. Now bond order is given by the formula half number of bonding electrons minus number of antibonding electrons. So for oxygen, as you know, oxygen has 16 electrons. So you know the sequence for oxygen: sigma 1s star, sigma 2s star. Then you have sigma 2pz, then comes pi 2px, which is equivalent in energy with pi 2py, and then you have pi 2px, which is equivalent in energy with pi 2py, and these are antibonding orbitals. And at last you have sigma 2pz star. So this is the sequence, increasing sequence of increasing in energy, the sequence of molecular orbitals. So 16 electrons, how will it be filled? It will be referred as maximum. Please don't forget, maximum capacity of each electron is 2. So 2, 4, 6, 8, 10, 12, 14. Now since these two are degenerate orbital, singly it will refer singly first. Hence rule. Okay? Now using this formula, now you can calculate the bond order in oxygen. So bond order in oxygen will be half bonding number of bonding electrons. So wherever you don't have this asterisk or star sign, those are bonding molecular orbital. 2, 4, 6, 8, 10. So you have 10 bonding electrons minus the electrons over the asterisk sign. 2, 4, 5, 6. So 10 minus 6. Here you have half into 4. So the bond order in oxygen is 2. That means between oxygen and oxygen atom you have a double bond. Okay? Similarly, now a question from here was asked from the concept last year too. So let us discuss that part. Okay? So bonding order and the sequence, you know it. The questions that they will be asking is, they will be giving you certain molecules, like you have oxygen, you have O2 plus, O2 2 plus, O2 2 plus, O2 2 minus, and you have O2 minus. So now they'll ask you to answer them either in increasing order of its stability or decreasing order of its stability. So how will you come to know? How will you know which one is more stable or which one is less stable? For that, this bond order is very, very important. Okay, this bond order tells us about the stability of the molecule, which ion or which molecule is very stable. Now listen to this very carefully. Higher the bond order, higher will be the stability. And if you have higher bond order, and if they ask you about bond dissociation energy, then stronger bond means what? Higher bond order means you will be having multiple bonding. That means they are very strong. That means their bond dissociation energy will also be strong. It will be more. So bond order, in a way, is directly proportional to stability. Number one, stability, and it is also directly proportional to bond dissociation energy. Bond dissociation energy. That means higher the bond order, higher will be the stability, and higher will be the bond dissociation energy. And bond order is inversely proportional. This is inversely proportional to bond length. Please remember these 3 points, okay? Bond length. So they can ask you based on any of these 3. Okay? So if you have higher bond order, means its bond length will be lower. Hope this is understood. Now let's discuss about the bond order for these molecules. And after knowing their bond order, we'll discuss about their stability. For oxygen, we have already calculated it is 2. So let me do it for oxygen. Oxygen is orbital, so let me write it here now. Okay. Let me write this sigma star, sigma 2p z star here. Now for oxygen we calculated bond order, just now we saw it. It was having 16 electrons and its bond order was what? 2. Now let's calculate for O2 plus number 2. O2 plus. Now O2 plus means what? Out of 16 electron, 1 positive sign means 1 electron has been lost. So 16 minus 1 is what? It has 15 electrons. Now if it has 15 electrons, then so bond order for oxygen, it was half 10 minus 6. 10 were the bonding electron and 6 were the anti-bonding electron, therefore you have 2. Now here bond order will be equal to half. Now if this sequence loses 1 electron, that means it has to lose from the outermost molecular orbital. That means one of the electrons from anti-bonding will be lost. This electron will be lost. Means the number of bonding electrons will be same. The number of anti-bonding electrons will be less, because in O2 plus 1 electron has been lost from the outermost molecular orbital, and here it is star sign, it is anti-bonding. Therefore 10 minus 5 will be equal to half into 5, which is equal to 2. So the bond order is 2. For oxygen it is 2. For O2 plus it is 2.5. Now similarly for O2 plus, how many electrons will be? O2 16 electrons. O2 plus 1 electron was lost, therefore 15. O2 2 plus means 2 electrons are lost. That means it has 14 electrons. So if it has 14 electrons, then see, up to this it was 16 for oxygen. Now if 2 electrons are lost, it has to be lost from the outermost molecular orbital. That means 1 electron from here, and this 1 electron from here will be lost. That means the number of bonding electrons will remain same, that is 10. But here from 6 now 2 electrons are lost. That means it has 4 electrons, and its bond order will now be 3. And here is 2.5. Please remember this, okay? 2.5, and this is 3. Now if you come to the fourth molecule, that is O2 2 minus, that means O2 itself has how many electrons? 16. Now 2 minus means 2 extra electron has come. That means it has 18 electrons now. Now if it has 18 electrons, up to here it was 16, 17, 18. That means both of them will be having 2 electrons. So up to here it is 14, 15, 16, 17, 18. So you can count it 2, 4, 8, 2, 4, 6, 8, 10, 12, 14, 16 and 18. Now this is for O2 2 minus. So now you can see that the bonding electron has remained the same. The electrons has come in what? Anti-bonding orbitals. So you can count it 2, 4, 6, 8. So 10 minus 8 will be equal to half into 2, which is equal to 1. The bond order is 1. Okay, so now likewise for O2 minus the fifth one, that is O2 minus, it will be having how many electrons? Up to here it was 80, that means one electron is less. First it will be filled singly, up to here it is 14, 15, 16, 17, so 2. 1, 17. O2 minus will be having 17 electrons. Its bond order will be equal to half. The bonding electron is same, that is 10 minus, now it is 7, will be equal to half into 3, that is 1.5. So we have calculated the bond order for each species of this oxygen, cation, anion. Okay, so let me write it here. This is bond order is 2.5. It is 3. Now for this O2, 2 minus it has been calculated as 1. And this for this it is 1.5. So 1.5, 2.2, 2.5, and 3. So can you see the maximum bond order is of O2, 2 plus. Then for oxygen plus 3, 2.5, that comes 2 for oxygen. Then for O2 minus, and at last you have O2 2 minus. So maximum bond order, minimum bond order. That means this is the decreasing. That means this O2 2 plus, since it is having a maximum bond order, now it will be the most stable. That means this is the decreasing order of stability. That means the one which is like at the first is the maximum. It has maximum stability, and as you go in the series, the stability decreases. Similarly, decreasing order of stability or decreasing order of bond dissociation energy. Bond dissociation energy. Okay, so this you have to remember, and this calculation is very simple. If you remember the sequence correctly, okay, that sequence is so important. Please remember that. Everything is based on that sequence that we discussed. Okay, from this lithium to nitrogen, you have different sequence, and for oxygen, oxygen, fluorine, and neon, you have different sequence. You have to remember that. Now, similar type of question can also be asked for other species, and the most probable one is of nitrogen. And for nitrogen, you have N2 plus, N2 plus, N2 minus, and N2 2 minus. Now, for this, your assignment, the way we discussed for oxygen, similarly you will be calculating bond order for each of these species, and please don't forget the sequence of nitrogen and oxygen is different. There should not be a mistake in that. Here you will be calculating the bond order of each of them, okay? Each of them correctly, and you will arrange them again in decreasing order of stability. This will be your home assignment. Okay? So this portion says every time the question comes from here, whether you are in class 11 or whether you will be going for your competitive examination, a series of questions will be asked based on this molecular orbital theory. Please take it seriously and do it by yourself. If you have any problem, please contact me. Stay safe, take care, bye bye.